That's kind of what Addie just said. So multiples to me would be, if I told you to count by a certain number, and you always use that number to go up. Right? So what are the multiples of 3? So basically, I'm counting by 3 every single time, right? So I can find the multiples, or have the multiples of any number in a sense, right? I would just have that series go on and on, okay? So that's what multiples are. The multiples of a number, or the number times a whole number, is being multiplied. So for instance, the multiples of 4 would be what?
4, 8,
12.
16, 20, 24.
And then we could just keep on going. Would it ever end? Heck no, right? As long as we could keep counting, it would never end. Okay? So we look at whatever number it happens to be. And so in other words, anytime that you hear the word multiples, you're thinking about counting by a specific number instead of just counting. That makes sense? So then, from there we talk about common multiples. And when we talk about common multiples, this would be where we would start to think about common denominators and stuff. So we would want to do, for common multiples, we're going to look for numbers that appear in 2 or more numbers list of multiples. So basically, if we were given 4 and 5, we already did or started 4 up here, and then if we did 5 down here, what would be multiples of 5? That one's easy, right? And we would keep on going until we either found an answer or we just had enough numbers that we thought we could find an answer. And so then we would look at trying to figure out what are the common multiples, or what is a common multiple on both of those numbers, right? So if we looked at this, we start out, obviously we can always keep in the back of the mind with 5 because it's got to end in a 0 or a 5. So the first one that ends in a 0 or a 5 with my 4s would be my 20. So common multiples would be 20 for sure, and then we could keep on going. Anybody know another one right offhand? 40 would definitely work, right? Anything else? 100's got to work, right? Okay? And so each of those would be common multiples. What our goal here is that when we start doing these kind of problems is to find the least common multiple. Now this is where people get confused because we've already done this kind of with what? Yeah. We already did this with factors, right? But with the factors, we've tried to find the what? The greatest common factor. So today we're going to find the least common multiple. And so this is obviously the smallest number in common between 2 or more numbers. Now, why would we want the least common multiple? If we found the smallest common multiple that we were going to use as our denominator, why would we want the smallest one? What does that make sure that we don't have to do at the end? Reduce? Yeah. So the only reason that we're looking for this really is this limits reducing. Okay. So again now, as we said this over here, if we were asked to find common multiples between 4 and 5, we circled 20, and that would be our least common multiple, but Addie said 40, and I came up with 100. Realistically, we could use each of those in our problem if we were adding and subtracting as our common denominator. But then, with Addie's or mine, we would have had to reduce our final answer. With the 20, you still might have to reduce, but it might not just be reducing really big numbers. Okay? So, the least common multiple, we're trying to find the smallest one. But what's a way to find any common multiple? How do I find a common multiple between any two numbers? So, for instance, if I'm given a fraction, or not even a fraction, but I'm asked to find the common multiple, and I can't see the number, meaning the list of numbers in my head, what's the easiest way for me to find a common multiple? It might not be the smallest one, but it's definitely a multiple that's in both.
Multiply the two numbers together.
Exactly right. So to find any common multiple, the easiest way to do this is to multiply the numbers together. Now, why wouldn't we want to necessarily do this all the time? And so why? So what would happen then? We'd have to reduce, and what else? Not only would we have to reduce, but if we did this with some numbers, what would that common denominator end up being? Could end up being a ginormous number, right? If I gave you 124 and 362, if I gave you those two numbers and we just did this, when we made our fractions, they would be really, really ginormous numbers, right? Because first, and then the other thing that would be a challenge for some of us, if we took our calculators away and you had to do 124 times 362, some of you, that would, one, take you about 2 hours to do one problem, and number two, you might mess up the multiplication. You know what I'm saying? Because we saw how good some of you were at that one day. Okay? But we can always do this, right? I could always punch it into my calculator, or I could do the math. Okay? So, just remember, when would this be okay? When would we want to just use any common multiple instead of the least common multiple? What do you think? When would it be okay for us to use any multiple? So the fastest way that I could find a multiple. Any idea? Okay, maybe if they're smaller numbers. Exactly right. But I would use this right here if my only reason for doing the problem is to compare numbers or compare fractions. Because then I don't really care what it is. If I'm going to use my inequality signs, my less than and greater than numbers or symbols, and put them in between two numbers, I can do this part right here because I don't care how big or small my fractions are. I just want to know which one's bigger or smaller between the two of them. Okay? But specifically, they might ask you to find the least common multiple because, again, it'll help you out. So, if I told you to try to do least common multiples between these two numbers, would you want to do this process right over here? Would you want to take 124 and make a list of all the multiples of 124? Well, first off, we might not even know the second one, let alone that, right? What's 124 plus 124? Right? 248. And then what? Right? It's kind of hard to actually think about that one, right? So, if they ask us to find the least common multiple, but they give us really, really big numbers, what can I do? So now, we're going to be specific and find the least common multiple, but with really big numbers, we're going to go back and use prime factorization. What did that mean? Yeah, perfect. So remember, this is a tree. And as Eddie said, to find factors that are prime. Again, now, what are factors? Yep. So the factors of a number are numbers that multiply together to get you to that big number. Okay, so let's just use these two right here. If I did 124 and I did 362, obviously both of them are divided by what? 2. Anything else with 124? Okay, well, let's do 2. What's 124 divided by 2?
62.
62. 2, prime number, 62.
31.
2 times 31, can I break down 31? No. So again now, once you get your prime factorization done, write it out. Now again, if you don't want to use exponents, that's fine. You can write it out using the numbers. Whichever is easiest to you. 2 times 2 times 31. Now let's do 362. So definitely divided by 2 again because it's even. Anybody do 362?
No. 181.
181. Everybody agree? So here's the question. Can I take 181 and break it down? That one's probably kind of hard, right? So let's think about our cheat codes. Can I use 2? No. Can I use 3? No. 4? 5? 10? 6? No. So 10 times 18 would be 180, right? So we got to kind of think between 10 and 180. Or sorry, 10 and 18. So 11. 12? No. 13? So I don't think there is any. So basically, what is this? It's 2 times 181. So again now, we're looking for the least common multiple. So the least common multiple, when you get to this point right here, you are going to use all parts of both prime factorizations. I'm too lazy to write prime factorization out again, so I'm going to say PF. So this is where it gets a little confusing for some people. When you do this right here, if you have the same base, and then on the other side you have the same base, but it doesn't have the same exponent, which one do you think you have to use? Do you use the smaller one or the bigger one? That's where it gets a little confusing. You're always going to use the bigger one. So in this case, see how I had 2 squared over here and I had just 2 over here? I'm going to use all the parts of both, but I'm not going to use both of these because they have the same base. I'm going to use the bigger of the 2. So my least common multiple would be 2 squared because that's in both. And then I'm going to use 31. And I'm going to use 181. And then I'm going to multiply all those together, and that's my least common multiple. So, what's 2 squared? 4 times 31.
121. No, 24.
Now do 124 times 181 on your paper. Go, practice. 124 times 181. us wouldn't be wrong. We're like the smartest people we know.
Yeah.
Ah.
Like, did you know that you can cook waffles?
Oh, we already did it, right? So it's 22,444?
Yep.
So if you actually did these two numbers together, you get the same thing. So this is actually the least common multiple also.
Wait for at least
I know. That's why it gets frustrating, right? Okay? So let's try this again. Let's do 16 and 24. So, I want to find the least common multiple. So again, if you don't want to make the lists, then you got to do the prime factorization. Okay? Now again, if they don't specifically ask you to find the least common multiple, and they just ask you to find any, I'm just going to always take 16 times 24 and get my answer. But now, probably want to do this. So remember, you got to use everything that's in the problem, but you always, if there's multiple parts that have the same base, you always use the bigger one. So this one should have been 2 to the 4th times 3, which is
48.
2 to the 4th is what?
48. Oh, that's 16.
48. Now, did anybody know that before they did the process? Did anybody just look at the numbers and say, hey, here's 16 and 24? I can just start saying, well, 16 times 3 is 48, and I can know that 24 times 2 is 48. So, what I'm getting at is, some of you might be able to start looking at these and just boom, you might just know them. And some of them are going to be numbers that you use over and over again, so you'll get used to them. Right? But if you don't remember, then this is a process that you can always use. Now again, if I was asked to find just a common multiple, and I didn't want to do all this work, I'm going to do 24 times 16. And I'm especially going to do that if we're allowed to use calculators, right? Because then I just plug it into my calculator and I find out what my least common multiple, or sorry, just a common multiple is. I don't care that it's not the least. Okay? So then we would have what? 4, 2, 12, 14, 0, 4, 2, 4, 8, 384. So we could have used 384 too. That is a multiple, but 48 is the least common multiple. So when you're doing your assignment, the quiz, the test, whatever, make sure you read the directions and answer the question for what the directions are. Some of you have problems with reading directions too. You do read, but I don't know about directions. I have seen you read.
I knew my frontal lobe is not developed yet.
You know, your lobe has a lot of problems. All right, any questions with the numbers? Do you want to see another example of the number ones? Okay, so then what happens when we use, or we want to do the same thing with monomials? Well, first off, what's a monomial again?
A term product. A variable or number.
A variable, a number, or a product, right? Okay, you said the definition in the definition, right? Because a term is just another word for a monomial, right? All right? So basically, this means this. If I had 12x squared y squared and 6y cubed. Okay, so we're doing the exact same thing, but now we're just doing it with monomials, or, as Grace said, terms. So when you do these, do the numbers the same. Whatever version of finding the numbers you did, you do that same thing. Did you make the lists? Did you just do the problem? Meaning, again now, are they asking for the least or just any? If it's any again, I can just multiply them together. If it's the least, then I either have to do my list or do my prime factorization. Okay? What about the variables? What do you think you're going to do with the variables? If I want to do this one, the variables, to me, are a lot like what we did when we did the prime factorization part. So in a sense, for the variables, I want to include all the variables. If something is in the original problem, it has to be a part of your common denominator or your least common multiple. Every single variable has to be included. Okay, so notice up here in our first example, we had one monomial that had x and y. This one over here only had y. In my final answer, I better have x's and y's as my least common multiple. Okay, I can't leave anything out. And then just like my prime factorizations, always use the bigger one. If it's the same variable. So this means the bigger exponent. So again now, if this is again to find the least common multiple, I always want to just use the bigger of the two. But if I want to find just some, I could just do like we did with the numbers over here and just multiply them together. So if I'm going to multiply variables together, do you remember what happened? If I take y squared times y cubed, you add the exponents, so we get y to the fifth, right? So let's talk about this one again now. What is this? If we're going to try to find the least common multiple, anybody know right offhand what the least common multiple between 12 and 6 are? 12, right? It's got to be 12. So we're good there. Now, we have to include everything. So I have to have an x and I have to have a y in my answer. Now, how many x's do I need? I gotta have 2, right? That's the only group of x's in the whole problem. So the only one that we really have to decide on, do I want to include y squared or do I want to include y cubed? And it's always the bigger exponent, so I'm going to use y cubed. Okay? So again, I'm going to include every single variable that's in the problem, but it's always the bigger one, meaning the bigger exponent. So let's try a couple more before the time runs out. Jacob gets 2 assignments because of wanting more problems. That's all I heard. 6a cubed c and, oh, that's bad again, 8a b c cubed. All right, try that one. See what you get. Remember, I want the smallest. the least common. Everybody got it? Number? Everybody agree?
Yep.
Okay? A to the B to the C to the same difference. Everybody agree? Okay? Need to see any more of those kind? Alright. So, what happens then if we have fractions like this? And we want to compare those two. Well, in all honesty, if you use common sense in this case, you probably could tell which is bigger in this, right? Because the 7's really close to the 8, so that's just about all of it, that one. And this one's 13's not real close to 20. So I would assume that 7/8 is bigger than 13/20. But I don't necessarily know that, right? So what are ways that I could compare these, meaning use my inequalities of less than or greater than? What would be ways of actually figuring out the answer?
You could see which numbers is common. I went to those, the denominator.
Okay? So I could find a common denominator. What else could I do? If I had a calculator, get out. Continue tomorrow.